Hello class, welcome to Geometry Lesson 3.5, which is all about symmetry. By the end of this lesson, you should be able to identify different types of symmetry in two-dimensional figures. Alright, so let's jump right into example 1, identify transformations for symmetry. So reflectional symmetry is probably what you're most accustomed to. It's all of those times that a reflection can map the figure onto itself. Or for those of you that say, I don't understand what that means, that's what you learned way back in elementary school, that if I were to draw this line here and fold it on that line, it would match up perfectly on both sides, right? It's reflected over that line. Or another line of reflection could be going across that way. Okay, so that is reflectional symmetry. That's the one that you've probably used the longest. Now, rotational symmetry, on the other hand, is maybe something that's a little new. I know you talk about it briefly in pre-algebra 2, but rotational symmetry is when you can rotate a figure and have it look the same. So if I take this second one, I want to see how many times can I get it to look like the top one. So if I rotate, it still doesn't look quite like that figure up top yet. But now that I've rotated like that, it looks exactly the same. So it has rotational symmetry at, that would be 180 degrees. I flipped it 180 degrees. And that was the only spot other than its original spot that had that rotational symmetry. So you'd say that this figure has 180 degree rotational symmetry. And point symmetry is actually the more specific name for that. If an object only has rotational symmetry of 180 degrees, another name for that is point symmetry. So point symmetry is a more specific type of rotational symmetry. So example 2, identify lines of symmetry. Here we have a hexagon, we have 6 sides. When you have a regular figure, however many sides they have, that is how many different types of reflectional symmetry they have. So if I take all of these and move them, you can see that all of these would be considered lines of reflection. So those 6 lines, don't make the mistake of saying I'll sometimes see people say, oh, there's 12 lines of symmetry. No, because remember, the line doesn't stop at the halfway point. If you're questioning, here's one line, here's a second line, a third line, fourth line, fifth line, and then our 6th line. So you can see I've traced over all of them. That is as many lines of symmetry as it has. It does not have 12. So be careful that you do not become one of those people that count all of the spots that touch the outside of the figure. All right, I want you to look at this figure and see how many lines of symmetry does this figure have. Hopefully you said 1 line of symmetry. The only line of symmetry it would have would be a vertical cut down the middle. To cut it like this would not work because this corner would not line up with this corner if we folded it horizontally. All right. Example 3, identify rotational symmetry. All right, so if we look at this triangle, we have an equilateral triangle here and an equilateral triangle. If I think about it, if we go off of what we learned on the last slide, there are 3 lines for reflection points. And when you have a regular figure, so remember a regular figure is when it has all equal sides and angles. What you can do is you can take 360, because when we rotate things, there's 360 degrees that we can rotate. And you can divide that by however many lines of symmetry you have. So remember, on the last slide, we had a hexagon, so we said there was a regular hexagon. So we had 6 lines of symmetry. Here we have an equilateral triangle, So we have 3 lines of symmetry. That means it's going to have 3 spots of rotational symmetry. So 3 goes into 360 120 times. So that means that this figure has 120 degree rotational symmetry. So that means that it has rotational symmetry at 120 degrees, at 240 degrees, and then again at, it would be 360 degrees. Okay, so you list the multiples of the rotational symmetry. Now, if we look at this parallelogram, this is not a regular figure, so we have to think about when it would look the same. So if I take this figure and I rotate it, it looks nothing like what it started with. If I keep rotating, now it's starting to look like what I started with, and there's what I started with. So it for sure has, that was 180 degrees. And then if I keep going, that was the only spot where it matched its original shape. So this one has 180 degree rotational. Or, what was another name for that? Point symmetry. All right, so I want you to look at these 2 figures and identify the rotational symmetry. So what are the rotational symmetries for each figure? And does each figure have point symmetry? Hopefully for this first one, you realized that you could rotate it and it would look the same 4 times. So you said that it had rotational symmetry at every 90 degrees. So it'd be 90, 180, 270, and then we're back to the 360. Go ahead and take a look at letter B. Hopefully you saw that the only time it had rotational symmetry was, sorry, it didn't stop, at 180 degrees. So this has 180 degree or point symmetry. All right, so example 4, determine symmetries. So for this one, I'm just going to talk you through it because this is all stuff that I've shown you on the previous slides. It's just putting it all together. So if I gave you that picture of that purple flower and I said, what types of symmetry does each figure have? Start with reflectional, okay? So look for those lines that you can draw through the figure and end up with a perfect reflection. So in this case, we have a line through the center of a petal is a line of reflection. Since there's 5 petals, there are 5 lines of symmetry, okay? So that is our reflectional symmetry. And then let's think about rotational symmetry. If there's 5 reflection lines, 360 divided by 5 is 72. So there's rotational symmetry at multiples of 72 degrees. So your final statement would be the flower has reflectional symmetry with 5 lines of symmetry and rotational symmetry for angles 72, 144, 216, and 288. You really don't need to add 360 on the end of that list. The book will not ask you for that number. If you write it down on a test, I won't mark it wrong, but it's really unnecessary because it just means that it's back to the original. Okay, and then letter B. If we look at this card, no lines of symmetry can be drawn. If these 2 dots did not exist, then we would have multiple lines of symmetry. But those 2 dots make it so we don't have any lines of symmetry. But if I were to rotate that card 180 degrees around the center, it would create an identical image. Therefore, the card has 180 degree rotational symmetry, or we call that point symmetry. All right, in example 5, this is something that I might have you guys do later on in the year. I'm not going to necessarily make you do it right now. But using symmetry, we have a company CEO wants a new logo that looks the same for each rotation of 30 degrees and uses the 3 company colors. What are some possible logo designs? So if there's 30-degree rotational symmetry, that means I need to figure out how many times can 30 go into 360 so I know how many sides of a figure we have. So I have 360 divided by 30 gives me 12, which leaves me with this shape, a dodecagon, a 12-sided figure. And then you need to carefully work with the colors in order to make it so it's symmetrical. Because if you had blue on this side and then purple over here, if I were to try to cut through, let's see, I need a different color to show this. If I were to cut through going like this, that would not be considered symmetrical because it's blue reflecting the purple. If I were to cut through like that, it would be symmetrical. But you need to be very careful with colors. That's something that I think this will be a project later on, so we'll talk more about that as we get closer. So here are 3 possible designs that could be used that would all be symmetrical. So you can see the first one's probably the most extravagant. The second one, still more challenging, like fairly challenging. They did a 12-pointed flower, it kind of looks like. And then the third one just had some lines and circles. So like I said, we'll probably do a project with this later on in the year, but not right now. We'll talk more about it when that comes around. And the last slide is your concept summary. So those of you that like to take the screenshot to have those things to remember, this is the page for you. If you have any questions at all, please, please, please feel free to reach out for some help and have a fantastic day.